Hello students, welcome to mathematics class. Students, this is part 2 of the chapter Algebra. In this part 2, we will discuss questions from the exercise 11.1. Students, coming to the question number 1, find the rule which gives the number of matchsticks required to make the following matchstick patterns. Use a variable to write the rule. In this question number 1, there are sub questions from A to G. So we will discuss one by one. Coming to the sub question a pattern of letter T as shown, two matchsticks using one horizontally, another vertically. We are asked to form a pattern. First, when I form a one T, I need two matchsticks. If I want to form two T's, I require four matchsticks. And if I want to form three T's, I need 6 matchsticks. You could observe here in the figure number 1, n says 1, which means number of T's that we are forming. Here in the figure 2, n is 2, which means I have got 2 T's formed. And in third figure, n is 3, which means I have formed 3 T's. Considering this n as a variable, number of matchsticks required to make the pattern of T's will be, for n equals to 1, it is 2 times 1, that is 2n I can say. For n equals to 2, it is 2 times n, that is again 2n I can say. For n equals to 3, it is again 2n. Here 2 is missing, let me write, it is 2 times n. Children, now the rule will be 2n, where n represents the number of T's that we are forming. So here the rule, you know, 2n, where n tells number of T's that we are forming. Now coming to the question number 1, sub question B, where we are asked to find the number of matchsticks required to form the matchstick pattern as a letter Z. So to form a letter Z, 1 we need 3 matchsticks. To form 3 Z's, I mean 2 Z's, I need 6 matchsticks. To form 3 Z's, I need 9 matchsticks. Here by counting you can check them, and 1, 2, 3, here one horizontally, another slanting, another horizontally. When we form one Z with 3 matchsticks, we are using matchsticks this way. So to form one Z I need 3 matchsticks, to form 2 Z's I need 6 matchsticks, to form 3 Z's I need 9 matchsticks. Now you could identify what is the pattern 2. Number of matchsticks required to make the pattern of Z will be certainly 3n. So where n is number of Z's that we are forming. Now coming to the sub question C, to form a pattern of letter U as shown, one vertically, another horizontally, another vertically. So totally we use 3 matchsticks to form one U, and to form 2 U's we need 6 matchsticks. To form 3 U's we need 9 matchsticks, and so on For 4 U's we need 12 matchsticks. So the pattern of making U's will require number of matchsticks 3 times the number of that we make number of U's. So the rule is 3n, where n is the number of U's. Now coming to the sub question D, a pattern of letter V as shown, slantingly 2 matchsticks are placed to form a letter V, and we need for one letter V 2 matchsticks, for 2 letter V's 4 matchsticks, and similarly for 3 letter V's we need 6 matchsticks, for 4 letter V's we need 8 matchsticks, and number of matchsticks required will be 2 times n, where n says number of V's. So rule is 2n. Now similarly we will go for sub question E, where a pattern of letter E, capital E, to be formed. Now tell me, how many matchsticks do you require to form one letter E? To form one letter E, we need totally, you could observe that here, very important, 5 matchsticks are required. 1 here, 2nd here, 3rd here, 4th, 5th. Like I have kept 3 horizontally, let me draw it properly here. So I have kept 1, 2, 3, 4 and 5, like this. So to form one E, I need 5 matchsticks. 1, 2, 3, 4, 5. So 5 matchsticks we require. To form 2 E's, I need 10 matchsticks. To form 3 E's, I need 15 matchsticks. Therefore, number of matchsticks required would be 5 times n, where n says number of E's that we are forming. Now coming to the sub question F, a pattern of letter S as shown here, we need 1 horizontally, again 1 vertically, 1 horizontally, again 1 vertically, and another horizontally, like this. So total how many matchsticks that I have used? 1, 2, 3, 4, 5. 5 only I have used. To form 1 S, I need 5 matchsticks. To form 2 S, I need 10 matchsticks. To form 3 S, I need 15 matchsticks. Therefore, number of matchsticks required will be 5 times the number of S's formed. So the rule is 5n, where n is number of S's that we are forming. Now coming to the a pattern of letter A. Now try to observe, children, here to form a letter A, I need 1, 2, 3, 4, 5, 6. So total I need 6 matchsticks to form one letter A, where n equals to 1. So to form 2 A's, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So where n equals to 2. Similarly, to form 3 A's, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here 12. 1, 2, 3, 4, 5, 6. Total 18. So where n equals to 3 gives 18 matchsticks requirement to form 3 A's. For to form a 2 A's, we need 12 matchsticks. To form 1 A, we need 6 matchsticks. Therefore, the rule is 6n. Why? Because I need 6 into number of A's, that many matchsticks. So children, with this I have completed main question 1. Now let us go for the main question number 2. Main question number 2 says, we already know the rule for the pattern of letters L, C and F. Where do we have learnt L, C and F? We have learnt in our previous session, that is part 1. In our yesterday's class, we learned that how many matchsticks are required to form n number of L's, n number of C's and n number of F's. We have already seen that. With that knowledge, sum of the letters from this question number 1 given above, that is just now we solved, give us the same rule as that given by letter L. See children, letter L requires 2n number of matchsticks. So similarly, which of the following that we have learnt in question number 1, the letters require same number of matchsticks? That is what he is asking. Which are those letters and why does this happen also we need to say. Now first, in our previous session, in our previous question, we got rules. I am writing rules, that is 2n, 3n, for u 3n, for v 2n, for e 5n, for s 5n, for a 6n. Now with this knowledge, rule for the following letters L, 2n required, for the letter C 3n required, for the letter V 2n required, for the letter F we require 4n, for the letter T 2n, for the letter U 3n. So we observe that rule for the L, that is 2n, and rule for the V 2n, and rule for the T 2n. So L, V, T, as they required only 2 matchsticks, they are the answer. So I have given reason. Similarly, since C requires 3n letters and here Z requires 3n letters, U requires 3n letters, so I can say C, U and Z. C, U and Z require 3n matchsticks. So C, U and Z. So these are the 3 letters. Now let us go for the main question number 3. Cadets are marching in a parade. There are 5 cadets in a row. What is the rule which gives the number of cadets given the number of rows? Use n for the number of rows. Here number of rows is given as n. Cadets in each row is 5. Therefore, total number of cadets will be 5 times n. So this is the rule. 5 times n is the rule. If I multiply number of cadets into number of rows, I will get total number of cadets in that parade. Now coming to the main question number 4, if there are 50 mangoes in a box, how will you write the total number of mangoes in terms of the number of boxes? Use B for the number of boxes. Here number of boxes is B and number of mangoes in each box is 50. Therefore, total number of mangoes will be 50 into n. 50 into n will be the rule, or sorry, 50 into B will be the rule, or tells total number of mangoes. Coming to the question number 5, the teacher distributes 5 pencils per student. Can you tell how many pencils are needed given the number of students? Use S for the number of students. So here, can you tell how many pencils are needed given the number of students, for the given number of students? So 5 pencils per student, number of students is S, and number of pencils distributed per student is 5. Therefore, total number of pencils required will be 5 into S. So here rule will be 5S to say how many pencils that we require to distribute. So where S represents number of students. Coming to the main question number 6, a bird flies 1 kilometer in 1 minute. Can you express the distance covered by the bird in terms of its flying in minutes? Use T for the flying time in minutes. Flying time. So distance covered by bird in 1 minute is 1 kilometer. The flying time is T minutes. Here T minutes. So using that T minutes will be total distance that it covers will be T into 1. So 1 T or T kilometers that it will cover, because in 1 minute 1 kilometer, so in T minutes T kilometers. So that is the rule. Now coming to the main question number 7, Radha is drawing a dot rangoli, a beautiful pattern of lines joining dots with the chalk powder. She has 9 dots in a row. How many dots will her rangoli have for R rows? So in each row she has 9 dots. So where how many rows are there? If you can say, we can say number of rows into 9 dots in each row will give the total number of dots. So number of rows are number of dots in a row drawn by Radha is here 9. Na? Oh, here I have made mistake. I have taken 8. Let me correct it. Students, here the question is, how many dots will her rangoli have for R rows, provided how many dots are there if there are 8 rows. So for 8 rows we have here, she has 9 dots in a row. So number of rows will be R and number of dots in a row drawn by her. So how many dots are there if there are 8 rows? These sub questions are second and third, and initially here 9 supposed to come here, and the number of dots required will be 9 into 1, 9 into 2, 9 into 3, and rule becomes 9R. So here 9R is the right answer. Then suppose if the number of rows 8, then 72 dots will be there, and if 10 rows are there, then 90 dots will be there. So these given in wrongly in textbook, so kindly correct it. 9R, because 9 dots are there in a row, so 9R is the rule, and if there are 8 rows, 72 dots will be there. If there are 10 rows, then 90 dots will be there. So these are the right answers. Then coming to the question number 8. In question number 8, Leela is Radha's younger sister. Leela is 4 years younger than Radha. Can you write Leela's age in terms of Radha's age? Take Radha's age be x years. Here Radha's age is x years. Therefore, Leela's age is x minus 4 years, because Leela is 4 years younger than, the word younger says less. So definitely 4 years less than Radha's age will be the age of Leela. Therefore, age of Leela is x minus 4 years. Next, coming to the main question number 9. Mother has made laddus. She gives some laddus to guests and family members. Still 5 laddus remain. If the number of laddus mother gave away is L, how many laddus did she make? So, she has already given L laddus, number of laddus gave away by mother is L, and number of laddus remaining is 5. Therefore, total number of laddus that she made is L plus 5. So, coming to the main question number 10, oranges are transferred from larger boxes into smaller boxes. When a large box is emptied, the oranges from it fill 2 smaller boxes and still 10 oranges remain outside. That means for one bigger box, 2 smaller boxes are equal plus 10 more. Okay. If the number of oranges in a smaller box are taken to be x, then what is the number of oranges in a larger box? Number of oranges in one small box is x, number of boxes 2. So, therefore, total number of oranges in the two small boxes into small boxes in one small box. So, 2x and remaining oranges 10, thus the number of oranges in bigger box is 2x plus 10. Now, coming to the main question number 11, look at the following matchsticks pattern of squares. The squares are not separate. Two neighboring squares have a common matchstick. Here, two neighboring square boxes have one common matchstick in terms of the number of squares. Hint, if you remove vertical stick at the end, you will get a pattern of C's. See children, here in first box I need 4 matchsticks, in second this pattern we need 4 plus 3, total 7. Here we need, is it 7 only? Yes. Then here we need 7, 1, 2, 3, 4, 5, 6, 7 plus 3, 10 are required for this. For this we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, 13 are required. Now, watch here 4, 7, 10, 13. If I take away 1, as they said, if I remove 1 from each these, 4 minus 1 gives 3, 7 minus 1 gives me 6, 10 minus 1 gives me 9, 13 minus 1 gives me 12. Could you observe here table of 3's? So, if we remove 1 from each of these, they make a table of 3's, that is 3, 6, 9, 12. Therefore, the pattern will be, or a rule will be, table of 3 plus 1, where x is the number of squares. This is a very simple. Number of matchsticks required will be number of square boxes into 3 plus 1. So, 3x plus 1 will be the number of matchsticks required. Similarly, I have a question number 11, sub question B, where triangles are formed, where find the general rule that gives the number of matchsticks in terms of the number of triangles. See, for forming one triangle I need 3, for forming 2 triangles in this way I need 5, to form 3 triangles in this way I need 7, to form 4 triangles I need 9. You could observe here, if I remove 1 from each of these, I will get 3 minus 1 as 2, 5 minus 1 as 4, 7 minus 1 as 6, 9 minus 1 as 8. You could see the table of 2's. So, number of matchsticks will be 2 times of number of triangles plus 1. So, table of 2's you are getting. So, 2 into number of triangles, 2x plus 1 will be the rule for this. So, the same explanation I give. If we remove 1 from each of them, they make table of 2's. Therefore, the required equation is 2x plus 1, where the x represents number of triangles. So, children, with this I have completed exercise questions of 11.1. So, wishing you good luck. We will discuss in our next class some more patterns and some properties on algebraic expressions. We will move further. So, till then, take care of yourself. Jai Hind. Thank you.